In this video, we are going to look at the percent yield of a chemical reaction. So let's start with a few terms and definitions. First, the theoretical yield. The theoretical yield is the maximum amount or mass of a product that can be produced by a chemical reaction. The theoretical yield is always a calculated mass that's calculated using stoichiometric calculations that involve the balanced chemical equation. The actual yield of a product is the amount or mass of a product that is actually obtained when you perform the chemical reaction. So if you have the actual yield and the theoretical yield, you can calculate something called the percent yield. The percent yield is simply a ratio of the actual and the theoretical yield. So we take the actual yield in grams divided by the theoretical yield in grams times 100, and we get the percent yield. So this basically gives us a measure of how effective or efficient our experiment was. If you have a very high percent yield, that means you produced, your actual yield was very close to the maximum mass that you could theoretically produce. And a low percent yield means that your experiment did not produce as much product as you could have theoretically. So given that, let's see if you can solve a problem involving percent yield. So take a look at this problem. It says without proper ventilation and limited oxygen, the reaction of carbon and oxygen produces carbon monoxide. And then we're given the balanced chemical equation. It says what is the percent yield if 40 grams of carbon monoxide is produced when 30 grams of oxygen is reacted with excess carbon? So this tells us that 40 grams of carbon monoxide is produced. So that is our actual yield when 30 grams of oxygen is reacted. So we could use the 30 grams of oxygen to calculate our theoretical yield of carbon monoxide. And then we could compare that to the actual yield. So pause the video and see if you can solve this problem. Okay. So the first thing we want to do is calculate our theoretical yield of carbon monoxide. And then once we've done that, we can use the actual and theoretical yield to calculate the percent yield. So the theoretical yield of carbon monoxide, we're going to start with the 30 grams of oxygen that was given. And remember that the oxygen is a reactant, so that can't be our theoretical yield. The 30 grams of oxygen is what we're given. We use the molar mass of oxygen to convert grams of oxygen to moles. Then we use our balanced chemical equation that tells us that for every 1 mole of oxygen, we can produce 2 moles of carbon monoxide. So that allows us to calculate moles of carbon monoxide. And then we can use the molar mass of carbon monoxide to convert moles into grams. And so 52.5 grams of carbon monoxide is our theoretical yield. That's the most that we can produce starting with 30 grams of oxygen. So now we can calculate the percent yield. The percent yield, we take the 40 grams of carbon monoxide, that was the actual yield that was given in the problem, and we divide it by 52.5 grams of carbon monoxide, our theoretical yield, times 100, and we get 76.2, and this has 3 sig figs, and that would be our percent yield. Try one more problem. Take a look at this problem, pause the video, take a few minutes, and see if you can calculate the percent yield. Okay, so in this video, or excuse me, in this problem, we're told that we have 5 grams of hydrogen. That's what we're starting with, and we are asked to calculate the percent yield. We're also told that we produce 16 grams of our ammonia. So the 16.0 grams of ammonia is what we actually produce. That's our actual yield. So as before, the first thing we want to do is calculate the theoretical yield, and then we want to calculate the percent yield. So calculating the theoretical yield of ammonia, we take the 5 grams of hydrogen that we were given, and we were told we had excess nitrogen. So we convert our 5 grams of hydrogen into moles of hydrogen using the molar mass of hydrogen, H2. Then we use our balanced chemical equation. For every 3 moles of hydrogen that we have, we can produce 2 moles of ammonia. So that gives us a ratio that allows us to convert moles of hydrogen to moles of ammonia. Our moles of hydrogen cancel, and our grams of hydrogen over here also cancel. Then we can convert moles of ammonia into grams of ammonia using the molar mass of ammonia. And so we end up with 28.2 grams of ammonia. That's our theoretical yield. So now we can calculate the percent yield. We were told in the problem that we actually produced 16 grams of ammonia, and we divide that by the maximum mass of ammonia we could produce, which is 28.2 grams, times 100, and this has 3 sig figs, so our answer would be 56.7%. So practice a few more of these percent yield problems. Be sure you're familiar with the terms and the concepts, and practice as many as you can.